Hi, grade 7. Are you fine? Today we are going to continue our lesson about the solutions. Part 2, Chapter 1, Solution, Solubility, and Concentration. A mixture review is a combination of two or more substances that do not combine chemically but remain the same individual substance can be separated by physical means. Two types, heterogeneous and homogeneous. For heterogeneous means different, consists of visibility of different substance or phases, solid, liquid, gas, can be separated by filtering. Example, this. Homogeneous mixture, homo means the same, has the same uniform appearance and composition throughout, maintain one phase for solid, liquid, and gas, commonly referred as solution. For example, salt and water. The solution is a mixture of two or more substances that is identical throughout, which is homogeneous, can be physically separated. Salt water is considered as solution. How can it be physically separated? Composed of solutes and solvents. Solute, solvent. The solute, the substance begin dissolved or being dissolved, such as iced tea mix. The solvent, the substance that dissolves the solute. For example, the water. The solution is the combination of these two, iced tea. The solvent is the largest part of the solution, and the solute is the smallest part of the solution. Types of solutions: gaseous, liquid, and solid solutions. In case of gaseous solution, for example, air, which is made of oxygen and nitrogen. Liquid solution, for example, drinks mix with water. Solid solution, this is the case of alloys, steel, brass, etc. Concentration. What is the concentration? The amount of solute dissolved in a solvent at a given temperature, described as dilute if it has a low concentration of solute dissolved. This case, which the solution in it is dilute. Described as concentrated if it has high concentration of solute dissolved. Look at the solute with respect to the solvent. Unsaturated has a less than the maximum concentration of solute dissolved. It can receive more. Okay. Saturated has the maximum concentration of solute dissolved, can see solid in bottom of solution. Supersaturated contains more dissolved solute than normally possible, usually requires an increase in temperature followed by cooling. Solubility, the amount of solute that dissolves in a certain amount of solvent at a given temperature and the pressure to produce saturated solution. Factors affecting the solubility of solids: the shaking, temperature. Increased temperature causes solid to dissolve faster. Shaking, agitation causes solid to dissolve faster. Particle size, smaller particle size, sized particles dissolve faster because they have more surface area. Note, increasing the amount of solute does not increase the rate of dissolve. Two kinds of solutions. Miscible liquids can easily dissolve in one another. Immiscible liquids are not soluble. In this case, the two liquids are miscible, but in this case, the two soluble are not. Okay. Polarity and dissolving. Chemists use the saying like dissolves like. Polar solute tend to dissolve in polar solvent. Non-polar solute tend to dissolve in non-polar solvent. Oil, for example, is non-polar while water is polar. They are immiscible. Solubility curves. Generally, the solubility of solid solutes in liquid solvents increases with increasing temperature. Look at the temperature and the solubility that increases proportionally for different kinds of salts. To read the graph, find the line for the substance. The amount that dissolves at a given temperature is the y-axis. How much KNO3 dissolves in 100 gram or 100 milliliter H2O at 50 degrees. Look at the KNO3. This is the green line. Okay, for 50 degrees. This is here. Okay. Find the line, the green one. Find the temperature and follow up to the line. Red arrow. Read across to the y-axis, and this is the answer, blue arrow. Since it is more than halfway between 80 and 90, it is 87. A point on the line is saturated solution. Above the line is supersaturated. Below the line is unsaturated. Using solubility curves, what is the solubility of NaNO3 in 100 grams of H2O at 0 degree? It is 73 NaNO3. This is the NaNO3, okay, at 0 degree, okay. How many grams of KNO3 will dissolve in 200 grams of H2O at 45 degrees? This is the H2O, okay, the KNO3, okay, 45 degrees in here. $150. How much water is needed to dissolve 190 of NaNO3 at 30 degrees? It is 200. This is the end of our lesson. Thank you for joining and hope that you are understanding well. Goodbye.